Welcome to Brain Vision.
So here we know that the torque needed is the moment of inertia of the system, or the merry-go-round, and the children, times the angular acceleration of the system. So we can, let's just say the subscript mgr would represent the merry-go-round. So we can say the torque would be equal to the the moment of inertia times the angular acceleration. This would be equal to the moment of inertia of the merry-go-round, which would be considered a disk. So here we'd use the moment of inertia of a disk plus the moment of inertia of the children on the merry-go-round multiplied by the change in angular velocity with respect to time. We can substitute and say that this is the torque would then be equal to 1/2 times the mass of the merry-go-round multiplied by r squared plus 2 times the mass of the child times r squared multiplied by omega final minus omega initial divided by t. And now we can solve. So the torque would be equal to 1/2, let's a little bit lower, would be equal to 1/2 times the mass of the merry-go-round, 760 kilograms, plus 2 times the mass of a child, 25 kilograms, multiplied by 2.50 meters squared. We're gonna factor out 2.5 meters because the r squared term occurs at both of these terms. Therefore, we can factor out the r squared term, and then again multiplied by 15 revolutions per minute, knowing that the initial velocity would be 0, and this would be multiplied by 2 pi radians for every 1 revolution, multiplied by 1 minute for every 60 seconds, all divided by 10.0 seconds. And we find that the torque needed is going to be approximately 422 Newton meters. So this would be your answer for part A. For part B, we want to find the force required. So here the force needed is going to be calculated from the torque and the radius. So we can say that the torque would be equal to the force perpendicular, or the force at the edge, times r sine of theta. And we can say that the force at the edge would be equal to the torque divided by r, or we can say 422.15 Newton meters divided by the radius of the merry-go-round, 2.5 meters. And we find that the force needed at the edge would be equal to approximately 170 newtons. So we have to round to 2 significant figures. This is your answer for part B. That is the. Thank you for watching.